implementing a trie, aka prefix tree. So with the help of trie, we can actually search for our word or search for its prefix. And it's pretty cool data structure. Um, it has more advantageous benefits rather than implementing some other way of where we need to search for a word or search for a prefix comparatively to dictionaries, hash maps, because in there's like if the number gets really enormous, we need more spaces in there, and there is a risk of facing collisions, hashing collisions. But in case of trie, we are saving everything in there, and it's just the length of this given board. So let's right jump into its implementation. So first thing first, for our trie, what do we need? We can actually create another class which will be representing our trie node, and this trie node will be taking it will have its hash map for given character. So for each character, it will have its trie node. So we will be building a tree basically. So this will be our children, and every time when it ends for a specific place of the word, we can mark it as if it was a word or not. So we need this word, and let's do our constructor. So for our constructor for this children, we'll just initialize it, hash map, and for this word boolean initially will be just false. Okay, now let's go into our trie class. So we will need our root for it, and let's also initialize this root, and this root will be new trie node. So we'll be calling our trie node class here, its constructor. So for insert, what we are going to do is that let's create our trie node, for this root, and we'll get every single character in our word. And in here you can insert and then to our children. So trie node to our children. Children is a map, so we can do compute if absent for given character. So if it is absent, there will be just empty trie node. In the end, after we traverse everything, the end of the trie node, we can just mark his word that we just went through all this given word character and mark it as true. So time complexity in this one, it's of n, where n is the length of this word. Another thing, we can optimize it. We can actually use indexes for this one rather than creating two-carry array, because two-carry array will be creating copies, but for just readability, I'm just using it this one, but we could optimize it this one just using it index. And for searching it, so we will need our trie node and this root. So again for each character of this given word, two-carry array. So what we are going to do, we will check if this if it contains in our children this given character or not. So if it doesn't contain, then let's just return false right away. So in our try node, so children contains key because it's a hash map. So if it doesn't contain, let's just return false right away. So we will just need to grab the next try node. So try node children, it's a map. So from here get C, which will give us a try node. And in the end, we can actually check this try node if it was a word or not, because we were marking every single word, and in here this is an end mark basically. So for given word, if in our tree, if it was a whole word, it will be just true. In case if it's not a whole word or it passed someone, then by default it's just false. Okay, so time complexity in here, same as insert. It has O of n, where n is the length of this word. And for search, space complexity is O of 1. We're not using extra space. And in here, space complexity is O of n, where in the worst case, we're creating a tree and length of this word. So let's just start with. So that is for prefix. And we can also find prefix in here. So this root. So for each character, let's go and traverse it. So for this given prefix, to char array, and if it doesn't contain, in our tree node children contains key for given C, then we can just return false. And in the yeah, let's do the next node, because we need to traverse it and see next nodes. Node children get C, and in the end we can just return true, because we don't really have to check if it's a whole word or not. In case if it doesn't exist, it will just return false. If this didn't return false, that means we actually have this prefix in our try. So let's run our code. And let's submit it. So for time complexity of this method starts with is the same as the others, O of n, where n is the length of this prefix string, and space complexity, we're not using extra space, so it's constant.